can you crack this circuit using Kirchhoff's laws? Wait, this looks tricky, but guess what? It's actually easy. Let's use Kirchhoff's laws and loop sign conventions to crack this question. Before proceeding further, let's quickly recap Kirchhoff's laws and loop sign convention. Kirchhoff's first law states the total current entering the junction in a circuit is equal to total current leaving the circuit. This first law is in accordance with conservation of charge, which means that there is no loss of current around a junction. Kirchhoff's second law states that the algebraic sum of voltages produced and the voltage dropped in a closed loop, a closed path, of an electric circuit is always zero. In Kirchhoff's second law, the total voltage or EMF around the junction is equal to the sum of products of current and resistance of all the loops. This law is in accordance with law of conservation of energy, which means that there is no loss of energy around the junction. Now let us understand how to form a loop and give sign to a current. This is done using Kirchhoff's loop sign conventions, so the direction of current is taken as positive if the direction of the current loop in circuit is in same direction to the direction of the loop we draw, and the direction of current is taken as negative if the direction of the current loop in circuit is in opposite direction to the direction of the loop we draw. You can see the loop draw here. This is an hypothetical loop ABCD. The direction of current in this loop is clockwise, moving from AB to BC to CD, and then from an opposite direction from A to D, which is anti-clockwise. Thus, the current I1 is flowing through resistance 1, current I2 is flowing through resistance 2, current I3 is flowing through resistance 3, and current I4 is flowing through resistance 4, but in opposite direction. Now we will draw a loop in a clockwise direction. Let's match the direction of current in the circuit and the loop we have drawn. The current I1 will be positive as direction of current flowing in circuit through resistance 1 and loop drawn is in same direction. Current I2 is also positive as direction of current flowing in circuit through resistance 2 and loop drawn is in same direction. Current I3 is positive as direction of current flowing in circuit through resistance 3 and loop drawn is in same direction. And current I4 is negative as direction of current flowing in circuit through resistance 4 and loop drawn is in opposite direction. Now we've done a quick recap of Kirchhoff's laws and loop sign convention. Over to my friend. She will explain Kirchhoff's loop sign convention in detail and will crack the circuit in an easy way. So over to her now.
So before understanding the proof, we need to understand the sign conventions for solving the loop. That is as per the loop or the voltage rule of the Kirchhoff's law. First of all, we are going to consider that if the direction of the current in loop is in the same direction of the loop we draw, then the current is taken as positive. And if the direction of the current in loop is in the opposite direction of the loop we draw, the current is taken as negative. Now, what do you mean by this? I'm going to tell you. So here, I always consider, now there are two directions. This is your clockwise and this is your anti-clockwise. By default, what happens? We always take the current. So now let us consider this an hypothetical loop. You can see here that the current is flowing from here A to B, then B to C and C to D. And here the current is flowing from A to D. Here this is not the actual circuit, this is the one part of the circuit I have taken, and these are the hypothetical direction of the currents that I have taken in order to explain this concept of sign conventions for the solving loops. So now I always prefer to draw the loop in the clockwise direction. So I'm going to draw the loop in the clockwise direction. So here I am drawing the loop in the clockwise direction, and for my understanding, I am drawing lot of arrows to compare. So now I am going to compare with each of the resistors. So we have the resistance 1, which is AB. Then we have the resistance 2, which is BC, and the resistance 3, that is DC, and the resistance 4, which is between A and D point. So the resistance 1 is between AB point, the resistance R2 is between BC point, the resistance R3 is between CD point, and the resistance R4 is between AD point. So now let us compare. This is the loop that I have drawn, and this is the loop of the circuit. Now we are going to compare. If in both the direction of the current is same, we are going to take it positive, otherwise we are going to take it negative. So now let us compare it with R1. You can see that the direction of the current is going from A to B, and our loop is also going from A to B. You can see here my loop is also going A to B, and here the current is from A to B. So the current I1 will be positive. Here it will be positive. From B to C, my loop direction is going downward, and here the current is also going downward. So the direction of the current I2 will be positive. Then you can see here my loop is going like this. The current is going, the current direction is also towards left. Here the current also towards left. So the current I3 will also be positive. But in the fourth case, my loop current is going upward, whereas in this case the current is going downward of the circuit. So this I4 will be negative. So in short, you have to compare the direction of the current of your loop that you're going to draw and in the circuit. If it is positive, same direction, this is I2 is positive, same direction, I3 is positive. But in the fourth case, they are in the opposite direction, so it is negative. So a simple rule will help you to solve all the circuits. So I repeat, if the direction of the current in the loop is in same direction of the loop that we draw, it is positive, and if the direction of the current in loop is in the opposite direction of the loop we draw, that is considered as negative. So this is another question of the Kirchhoff's law. In this we are going to use the two laws of Kirchhoff's law, and we are going to use the rule for the loop that I have explained you, that the current in the direction of the loop is taken as positive. So first of all, let us just revise the two Kirchhoff's law. Junction rule or the current loop. It says that the total current entering the junction is equals to the total current leaving the junction. This is as per the conservation of the electric charge. And the loop or the voltage rule says for the closed loop, the total EMF is equals to current into resistance, and total EMF or the total potential difference across the full loop, full circuit, is equals to 0. So we are going to use these two rules, and we are going to use the loop rule that I have explained to you earlier, and we are going to solve this question. So let's start. First of all, we are going to apply the loop. As I've told you that by default you should always start the loop from the positive and end towards the negative. In the direction of your loop will be positive. So first of all, you are going to make the loop segregate the current. Remember to follow the junction rule. That means total current leaving the circuit should the total current entering the circuit. So you have to follow that current rule. So if I'm going to start the current from here, let the current will be I1. So that means the current I1 is passing through this 2 ohm, and the current 1 is reaching here. So because from here there is another battery, there is another potential difference, and both of them are different, so we cannot take the same current. So I have to start current 2. So that means current 2 is starting from here, and both of them are reaching here. So from the C point, current 1 2 are passing. That means from this 8 ohm, current 1 and current 2 are passing, and they are reaching here. That is current 1 and 2 will go down again, reach the negative terminal of the battery. So that means the total current I2 which is leaving battery of the 2 volt is entering. Same case here, the I1 current, it is going to go this internal resistance also, and it is going to reach the negative terminal of the battery. So the two important things that you have to segregate, first of all you have to draw the currents. That means the total current entering should be the total current leaving, or vice versa. And your second is that draw your loop should start from the positive and it should end to negative. Now we are done with the two segregation. Now the third step is to run, and then we are going to solve equations. Now, the third step is to create the equations. As I've told you that we have to check for the current and the direction of a loop. So this is the direction of our loop. So you can see here that the current is going from the left, and here also the I1 is passing through it. So this I1 is I'm in the so I'm going to write it down. Now here we are going to apply the second law, that the total EMF is equal to current into the resistance. So for this loop ACDB, the total EMF is given as 1.5 volt. So this is, we are going to write it down on the right hand side, and on the left hand side we are going to take the EMFs or the potential of the currents and the respective resistance. So as we know that the potential difference or the EMF is equals to V is equals to IR. So in that case, the current I1 is passing through the 2 ohm. So, and as the direction is same as that of the loop, so in this case it will be V is equal to IR. That means I1 you're going to add. Now you're going to see the direction of the loop is this way, and the so so in this case, as the current I1 and is in the same direction of a loop and it is passing through 2 ohm, so V is equal to IR, that is 2 ohm into I1. Now we are coming to this loop. This current passing through the C, that is passing through this 8 ohm, and our loop direction is same, so it will be I1 plus I2 into 8 ohm. Then we come to this D point, and we are going to take it this I1 upward. I1 is passing through 3 ohm, and our loop direction is also in the same direction, so this will be I1 into 3 ohm. And the last of all, the current is going through the B, and there is no junction, so it was going to go in the series only, and it is passing through this small internal resistance 2 ohm, and we are going to add this also, I1 into 2 ohm. So remember, when you're taking the EMF of the whole circuit, you have to consider the external as well as the internal resistances, and it will be equal to the total EMF or the potential given across this loop. So practically this is the equation which I'm writing it here, that is the equation for AC BD will be 2I1 plus 8I1 plus 8I2 plus 3I1 plus 2I1 is equals to 1.5. So if we are going to add them, that is 2I1, 8I1, 3I1 and 2I1. So this is going to give me 5I1 plus 8I2 is equals to 1.5. So this is my first equation that I have solved. Now the one confusion comes, that how many equations we should take. So as I have told you earlier, that the equations are based on the number of currents you have. So here you have two currents. Here you have I currents. So you are going to consider only two equations. If there were three currents, you should have considered three equations only. So now the second loop I'm going to consider is ECD FE. In this case, my loop is going in this direction. Let's see. My the current is going in this direction, and the I2 is also going in the same direction. So in this case, I2 into 2 ohm. Then add. My loop direction is going towards the right, and the current is also going towards the right. So this will be I1 plus I2 into 8 ohm. Now the current I2 has reached this point D. It will get segregated because D is a junction. So now I2 is passing through the 3 ohm, and it is in the same direction of my loop. So this will be 3 into the I2 plus, now the I2 is here, it is going through this internal resistance, that is 1 ohm, that is I2 into 1 ohm, that will be equals to the EMF across this loop, that is equals to 2 volt. So now if I consider the equation across this loop, ECD FE will be equals to 2I2 plus 8I1 plus 8I2 plus 3I2 plus I2 equals to 2 volt. Now if I solve this equation, we have 8I1 and we have, that's it, and I think 8I2, 3I2 plus 2I2 plus I2. So in this case, how many I2s will be there? 14I2 plus 8I1, that will be equals to 2. So this is the second equation that you're going to solve. Now we are going to apply the mathematic concepts of solving the equations simultaneously. So I'm writing these two equations here. My first equation was 15i1 plus 8i2 is equals to 1.5, and my second equation is 8i1 plus 14i2 equals to 2. So now what you can do, you can multiply this with 8 and you can multiply this with 15. So on solving these two equations and calculating the value, your value of the current one will come out to be 5 upon 146 ampere, and the value of the current I2 will come out to be 18 upon 146 ampere. We have to see what was there in the question. Okay, so here using the Kirchhoff's law, find the potential difference at the end of 8 ohm wire. So this is our 8 ohm wire. So you have to find the potential across here. So this is the point that you have to find the potential. So now finding the potential, what we are going to do. So the potential, that means V across 8 ohm wire, I1 plus I2 into R. So in this case, you're going to add this 5 upon 146 plus 18 upon 146 into 8 ohm. On solving this, you should get the value 92 upon 73 volt. So here you have to be very careful in solving these equations mathematically. Either you can use the elimination or you can use the substitution method to solve it. My other videos, mathematics videos of linear equations, I have explained how to solve two equations through elimination and substitution. You can check that video to know how to solve these equations.
Hope you understood the concept easily. For more helpful videos on Kirchhoff's law, don't forget to click the link below. Also, keep watching Transy Learning for more easy-to-follow videos on Kirchhoff's law and other concepts. In our upcoming circuit videos, we will show you how to crack the circuits shown using Kirchhoff's laws and sine loop conventions. So stay tuned with Transy Learning. Thank you.